Okay, so this is a video to help you try to understand how math magic really works. And I, the great Thadini, will get ready to show you all that I know and possess when it comes to math. All right, so it says to pick any positive number, write it at the top of the Math Magic page. So if you were not here on this day, or even if you were, possibly you picked a favorite number and wrote it at the page, at the top of the page. Okay. Then the instructions said to follow each line and perform the operation on that number. So to write the instructions to the right and then to come up with a number. And so it first says to double the number. Okay. And mathematically, that means 2 times 8, which gives us 16. Okay. So we did that one. Then it says to add 6. So we take our number 16 plus 6 and we get 22. And we figure that one out. Then it says divide by 2. Divide by 2, so 22 divided by 2 gives us 11. And subtract the original number from the new number. So subtract original number from this number, current number. So I would take 11 minus 8 and I would get 3. Fold your paper hot dog style so your page can't be seen. And if you picked your favorite number and performed all these operations, the kids were told to fold their papers in half. And then I, the great Thadini, came around, looked at the face of a few students, and I tried to guess the answer. Says, I will now use my psychic powers. And I said that the answer to all of the students' simplified expressions was, actually, I'm not going to say that. I went around and wrote down what I thought the answer was. Okay? And then the kids that I did go to and wrote down the answer, did I get their answers correct? Yes. All the students that I went to said that I was correct. The great Thadini. So then I was like, wow, that's pretty impressive. I, the great Thadini, know all, possess that power. And then we said, well, did you all start with the same number? And no, there were various numbers. As you saw in what I showed, I had 8. There were people who had 13 and 7 and 2 and any various numbers. So, was it really math magic? Am I really the great Thadini? No. How does that work? Well, the answer to all of their problems in the simplification of what we were looking at before, the answer was 3. And I wrote down the number 3. Okay? And the way this works is by using algebraic expressions. Okay. Okay, using algebraic expressions, performing certain operations on those algebraic expressions to remove any variables which would include the original number, because everybody had an original number, and to ensure that the simplification of expressions resulted in 3. Now, let me read this again because it's hard to think and write and sometimes at the same time. So, how did this math magic work? It really wasn't math magic. The answer was always 3 to all of the students' answers that they wrote down. So by using algebraic expressions, performing certain operations, like by multiplying or subtracting or adding or dividing on those algebraic expressions, we were able to remove any of the variables, which included your original number, because as a variable, we could represent that as a variable because it was a varied number. And then we had to ensure that the simplification of expressions resulted in the number 3. Okay? So let's take a look at this using a couple of examples. So verbally we say, choose a number. Well, we've got our examples here. Let's say they chose 2. And so once you choose that number, the next directions, I believe, I have to go back now, were to double the number and add 6. Oh, I forgot to write that down. So when we start with x, okay, we chose a number, and then we said, let's double that number. Okay, so if we started with x, doubling it would give you 2x. If my number was 2, doubling it would be 2 times 2, which is 4. And we might as well go ahead and do this other example here. This would be 2 times 5, which is 10. Modeling it, if I have something of a star, and again, the star kind of is representing a variable, I would say I am doubling it, so I have now 2 stars. The next set of directions say to add 6. So if I add 6 to my algebraic expression, I get 2x plus 6. If I add it to 4, I say 4 plus 6 gives me 10. And if I add it to 10, I get 10 plus 6 gives me 16. And if I add it to my model, we don't know right now technically what these stars represent. It's just some sort of a model. So by adding 6, I'm going to say my 6 are these circles. 1, 2, 3, 4, 5, 6. Okay. My next directions say divide by 2. So I'm going to divide by 2. And if I divide 2x plus 6 divided by 2, I'm going to do this right here. That's the same as factoring out that 2. I have 2 times x plus 3. Divide this by 2. 10 divided by 2 is 5. And 16 divided by 2 is 8. And if I take this and divide it into 2, I have this here on the bottom. Okay. The next says to subtract. Oh, I forgot to do this. So I factored out the 2, and then dividing by 2, the 2's would simplify out. I'm left with x plus 3. So there's my x plus 3. So here, my last verbal command is to subtract the original number. Subtract the original number. So I have x plus 3 minus x. My x's would cancel out, and I am left with 3. So here, when I use an actual number, I have 5 minus my original number here, which was 2, which leaves me with 3. Here I have 8 minus my original number, leaves me with 3. And over here, if I take away 3, that means crossing those out. Whoops, nope. My original is the star. So if I remove the star, then I am left with 1, 2, and 3. So we always got that answer of 3. So if you look, when you start with that variable, and again, you perform different operations, you doubled it, you added 6, you divided by 2, and then that left you to subtract your original number or amount. Well, you were subtracting that variable, and you made it to work out to be 3. Okay? So there's really no magic trick in it. All right, so here it says, get a calculator, ask your classmate to try the following. Again, we did this in class. Classmate must press enter or equal between every step. So it says, letter A, enter the month of his or her birth into the calculator. So for May birthday, they would enter 5. All right. Mine is coming up in October, just letting that you know, putting it out there. So that would be 10. So I have an October birthday, October 6th. Okay, so October, multiply that number by 7. So 10 times 7 gives me 70. Subtract 1 from that, 70 minus 1, 69. Multiply this by 13 on my handy dandy phone here. So 69 times 13 is 897. Add the day of birth. So my date of birth is the 6th. That would be 897 plus 6, which gives me 903. Add 3. So 903 plus 3 is 906. Multiply that number, 906, by 11 gives me Oh shoot, I should have. So 906 times 11 gives me 9,966. Subtract the month of birth. So 9966 minus 10 gives 9956. Subtract the date of birth. 9956 minus 6 gives 9950. Divide by 10. 9,950 divided by 10 gives me 995. Add 11. That gives me 1,060, I think. And then divide that by 100. And that gives me 10.6. 10.6. Or in other words, as you look up here, October 6th. Wow. That is so cool. All right. So how does this work? Okay, so again, we can substitute in, because we all have different birth dates, you can substitute in with a variable. So let's say our month is going to be N. Well, let's do M. M for month. M is equal to the month of the birthday, and we're going to say D is the date of the birthday. So, performing these calculations step by step and simplifying after each step says to take whatever that month is, whatever that number would be for birthday months, it would be somewhere between 1 and 12, multiply that by 7. So, M times 7 gives us 7M. Subtract 1 from that. So 7M minus 1. And that is in simplified form. Multiply this result by 13. Well, since we can't simplify that, I need to multiply the whole expression by 13 and then simplify it. So that becomes 91M minus 13 after I distribute. Then it says to add the day of birth. So 91M minus 13, and my date of birth, I'm going to say, is plus D. Add 3. So that is 91M minus 13 plus D plus 3. And when I simplify that, my negative 13 and plus 3, I get 91M minus 10 plus D. Okay? Multiply that by 11. Oof. So that is 11 times 91M minus 10 plus D. All of that needs to be multiplied by 11. Running out of space as usual. So 11 times 91, because I need to distribute, equals 1,001 minus 11 times that negative 10, that's a minus 110, and then plus 11 times D is 11D, plus 11D. All right, subtract the month of birth. So now I'm going to subtract, I'm going to see if I can do it this way, 1D. Okay, subtracting that 1D leaves me with 1001 minus 110, and 11D minus 1D is 10D. Subtract, oh shoot, I dropped an M somewhere. You probably already saw that. Okay, so 1001 M, going back up to this line right here, 1001 M minus 110 plus 11D. Then it says subtract the month of birth, which my month of birth was an M, so subtract 1M. That leaves me with 1000 M minus 110 plus 11D. Then it says subtract the date of birth, so subtract a D. That leaves me with 1000 M minus 110 plus 10D. Then I need to divide everything in here by 10. So 1000M divided by 10 is going to be 100M minus 110 divided by 10 is going to be 11, and 10D divided by 10 is going to be D. Okay. The next line, K, says to add 11. So I will add 11 here, and negative 11 and positive 11 cancel out. So I have, my simplified expression is 100M plus D, and then it says to divide by 100. Divide by 100. So 100M divided by 100 leaves me with M. And D divided by 100, if D is any number and you divide it by 100, you go 2 places to the left. So this would be plus 0.0D. So your month plus 0.0D should give you 10.06, October 6th. And there it is. Ooh, and I say I did this incorrectly over here. Well, you know, this was like the 3rd time I've done it. The second time, or the first time, I guess it's only the second time. Well, the first time was in class. The second time I tried to do this, the volume wasn't working. There we go. 995 plus 11 is 1006. And so 1006 divided by 100 is going to work out even better to give 10.06. Now they match up exactly. Exactly. Okay. So again, it's a matter of knowing that if everybody has a choice, they can start with a variable, performing operations on those variables, and you can perform whatever operations you want to. Make sure you simplify as you go, and at the end, take away or undo anything and force the answer to be what you want that answer to be. So it is not math magic, but it sure does seem like it at some points. Okay. Create your own math magic trick. We did not get a chance to do that in our classes, but here it is, writing algebraic expressions. So I will go ahead to do that. 3 times a number minus 7. 3 times a number minus 7. You need to remember order of operations here. We've got PEMDAS, or as I say, PEDMOS, because multiplication and division happen from left to right. Same as addition and subtraction, left to right. So 3 times a number minus 7 means you would be multiplying first before you would subtract. So that is going to be 3n minus 7. Number 2, a number minus 7, comma, that comma is important, then multiplied by 3. So a number minus 7, that whole thing together, then the result is multiplied by 3. Okay. A shirt originally cost $C. It's on sale for 60% of the original cost. 60% of the original cost. So the question here is, what are they looking for? They're looking for the discount or the new price of the shirt. I'm thinking the new price of the shirt. So the shirt was originally C. We are going to have to subtract the discount. And the discount is 60%. Many of you are like, okay, minus 60%, minus 0.60. But we don't know what that cost of the shirt is. So it's 60% of the original cost. That means you need to multiply 0.6 times C. So that gets multiplied first, then you subtract that result from the original shirt. Number 4, the total number of hours worked during D days for a person working 7 hours each day. 7 hours each day would be 7 times D number of days. And then finally, the total amount of pay for working H hours at a wage of $7.25 per hour would be $7.25 times H number of hours. Okay. So now between that and the math magic, hopefully you have a better understanding of how this math magic, math trick actually works. I look forward to seeing you guys this next week, and we will be starting on our next chapter of equations.